This is Lab 26, Example 5. We want to create polynomials with intercepts at x equals -2, 1, and 6, whose graph matches the graph. The graph is on this piece of paper. It looks like this. What we can tell from this is that it goes from up and then it ends upwards as well. So it ends up and goes up. So I'm going to mark that down. So it goes up from the left and up from the right. So it goes up, up. And if we notice here, it already gave us where our zeros are, is -2, 1, and 6. And we can kind of look at what those zeros do. So we notice here at -2, it bounces off the x-axis. So that means when we have x equals -2, that this has an even multiplicity. And for the rest of our zeros, they pass through the x-axis, which means for x equals 1 and x equals 6, we have odd multiplicities. So essentially we're going the opposite direction with what we did for examples 1 through 4. We're looking at the graph and then figuring out what the function will look like. So we know that we have intercepts at x equals -2, 1, and 6, and we know this information. Because we know that it goes up, and we have an even multiplicity and odd multiplicity, that means that we're going to have an overall odd degree. So if we actually go over here, we know that we go up on the left and the right, and the only thing that gives us that is a is greater than 0 and an even degree. So we know that our a is greater than 0 and we have an even degree. So knowing all this information, we can create a function y, and we know that our a is greater than 0, so let's just assume that it's going to be 1, because we can assume it's 1. And so we're going to have x, and we want to have it at -2, so this is going to be x minus -2, or just x plus 2. It's going to have an even multiplicity. That could be 2, that could be 4, that could be 6. I'm going to keep it at 2. And we also have a 0, x is 1, so that's going to be x minus 1. Has an odd multiplicity, so I'm just going to leave it as 1. And we have another 0 at x equals 6, so that's x minus 6, and it also has an odd multiplicity, and I'm going to leave it at 1. So this is one example of a function that would fit that graph. There's others probably that could also probably fit that graph if there was less information, but from what we have, this is the most basic example of a polynomial that will fit it.